So to find this derivative, we have two different functions of x dividing one another. So that lends itself to the quotient rule. The quotient rule says the derivative of the top function, which you can call f of x, times the bottom function kept the same, subtracted by the top function times the derivative of the bottom function, all over the bottom function squared. So the derivative of cosecant, if you're not sure what that is, here we can make a separate little equation. That is our f of x. Let's call that f of x equals cosecant x. That's the same thing as 1 over sine of x, right? And to find this derivative, you could again use the quotient rule. Derivative of the top function times the bottom function kept the same, minus the top function kept the same times the derivative of the bottom function, which will be cosine of x, all over the bottom function squared. And so if you simplify that, that's negative cosine x over sine squared x. But another way of writing that, we have 1 cosine over sine, so that's negative cotangent x. And then you have 1 over sine of x left over, so that'd be cosecant x. That's the derivative of cosecant of x. It's negative cosecant x, cotangent x. Okay, so we needed the derivative. Sorry, I should have said that's the derivative. So the derivative of f is negative cotangent x, cosecant x, and then g is x. So those are different functions multiplying. Minus f kept the same, which is cosecant x, times the derivative of g, so that's 1. It's all over x squared. So that's it. There's nothing I can see that we can really clean up. You could factor out maybe a negative cosecant x, because each term has a cosecant x. And factoring out a negative would at least make each term positive. Gets rid of, there's an x attached to this one too, right? So I'm going to put the x out front. Factored out a negative 1. So that's the same thing. Both these are the same thing. This just looks a little better. So negative cosecant x times x cotangent x plus 1 all over x squared.